Out there, beyond the edge of sunlight, a tiny human-made machine is still whispering across the abyss. 47 years after launch, Voyager 1, a spacecraft built when home computers didn't exist, has just done something impossible. It turned back. For reasons no one at NASA can explain, the most distant object ever created by human hands altered its orientation toward the very system it left behind. And then it sent back data so strange that the scientific world froze. What could make a dying probe billions of miles from home twist in the dark? And what did it see in the silence between the stars? It all began in 1977 when Voyager 1 and its twin 2 were launched to ride a once-in-a-lifetime alignment of the outer planets. With less memory than a digital watch, they were never meant to survive half a century. They gave humanity its first glimpses of Jupiter's storms and Saturn's rains. Then, as their cameras shut down, they kept going, beyond Pluto, beyond every boundary we had drawn. Voyager 1 became the first to cross the heliopause, the invisible frontier where the solar wind dies and interstellar space begins. But when it crossed, something was wrong. The magnetic fields didn't shift as they should have. The plasma density spiked, but the field direction stayed the same, as if the probe hadn't left our solar system at all, but entered a mirror of it. For years, scientists believed Voyager 1 had truly escaped. But new data showed subtle fluctuations in plasma waves, like echoes bouncing between unseen walls. The heliopause wasn't smooth, it was rippling. Then in 2018, Voyager 2 crossed the same boundary and detected the exact same anomalies. Two spacecraft, 6 years apart, both finding themselves trapped in identical magnetic conditions. NASA's models couldn't explain it. The simplest conclusion, that the probes hadn't actually left, raised a bigger question. What is really out there? Was the heliosphere not a bubble, but a barrier? In late 2024, Voyager 1's datastream changed. Its cosmic ray detector began registering short, rhythmic spikes, each precisely 11 minutes apart. NASA dismissed it as system noise. But the spikes were perfectly timed. Then came the glitch. Voyager 1's antenna, which hadn't moved in over a decade, suddenly reoriented itself by half a degree. The maneuver was tiny, yet it required a deliberate command from its attitude thrusters, commands that had not been sent. The spacecraft had turned back. And when it did, the data changed. The rhythmic spikes merged into a continuous tone. When the waveform was decoded, it formed a repeating harmonic ratio matching the fundamental frequencies of the hydrogen atom, the same constant used to encode the golden record, Voyager's message to the stars. That discovery split the scientific community. Some argued it was a coincidence. Others thought something profound had occurred. Voyager 1 was hearing its own transmission reflected back. The data patterns were identical to the probe's own signal profiles from decades earlier, but inverted, as if bouncing off an unseen boundary. A reflective membrane surrounding the heliosphere, absorbing and returning signals like an echo chamber. The signal grew stronger for 3 weeks, then vanished. When engineers analyzed the final frames, they noticed one last faint voltage fluctuation. It wasn't random. It spelled out a binary sequence matching the timecode of the golden record's very first track, Greetings from Earth. Voyager 1 hadn't just looked back. Something had looked back at it. Engineers at JPL worked around the clock. When they filtered the raw binary, the resemblance was undeniable. The frequency envelope matched one of the probe's original calibration tones, but reversed, as if bounced off something vast and structured. Using reconstruction models, the team converted the waveform into a 3D spectrogram. What emerged on the screen froze the room. The signal wasn't chaotic. It had symmetry. 6 repeating spikes formed a perfect hexagonal lattice, like a crystalline arrangement. The implication was staggering. Whatever Voyager had encountered was not a diffuse gas cloud. It was an organized boundary, an interstellar wall, behaving like a membrane. The discovery couldn't be contained. Observatories across the globe began tuning to the same frequency. They all reported identical phenomena, tiny, mirrored pings arriving exactly 19 hours after every Voyager 1 transmission. The time delay corresponded precisely to radio waves bouncing between Voyager 1 and an object on the other side of the heliopause. It was a two-way feedback loop. Then came the impossible moment. The same mirrored frequency appeared on Voyager 2, billions of kilometers away, synchronized to the second. Once both Voyagers were receiving the signature, NASA tried to decode it. What emerged looked like geometry. Plotting each frequency spike over time, the peaks formed an expanding spiral intersected by radial lines, like a map. The coordinates aligned with local interstellar clouds, forming a corridor stretching toward Ophiuchus. But the map wasn't pointing outward. It was folding inward, converging back on the Sun's position. It was as if the signal were charting us. When engineers converted the ratios into audio, a haunting low-frequency hum emerged, oscillating precisely at 115 Hz, the hydrogen tone from the golden record. Something was speaking in the same mathematical language we had sent as a greeting. On February 4, 2025, Voyager 1's sensors triggered another automatic correction maneuver, uncommanded. The probe rotated 7 degrees, aligning its high-gain antenna not toward Earth, but toward the exact coordinates indicated by the geometric pattern. For 11 minutes, Voyager transmitted a high-power burst straight into the darkness, as if answering a call. Every dish in the DSN registered a power drop, followed by silence, and then a return signal far stronger than anything the spacecraft could detect. The echo wasn't in radio. It arrived as a low-frequency gravitational fluctuation, a ripple measured simultaneously by the LIGO detectors on Earth. A human-made machine had sent a signal into the abyss, and spacetime itself had responded. When the gravitational echo arrived, every model in physics broke. It wasn't just a ripple, it was a patterned wave encoded with intervals that matched Voyager's transmission. When reconstructed, the waveform wasn't noise. It was a shape, a toroidal lattice pulsing and breathing. The coordinates embedded within it matched the exact position of Voyager 1. Some called it interference. Others whispered that Voyager had touched an artificial construct, a gravitational shell surrounding the solar system. NASA went dark. All live telemetry from Voyager 1 was redirected. Officially, the spacecraft was experiencing data corruption. The final packets received from the probe contained a compressed burst of raw measurements. When expanded, it revealed a repeating code embedded in the plasma readings. 101111. A pulse repeating every 11 minutes, identical to the signal Voyager had first detected. But this time, the source wasn't beyond the heliopause. It was behind the probe, inside the heliosphere, following it. That was when the DSN captured something impossible. A second signal, not from Voyager, but from somewhere between them. It matched the probe's frequency but was far stronger. For 19 minutes, it mirrored every Voyager transmission in real time, duplicating its telemetry. It was as though there were two Voyagers, one human, one reflected, echoing each other in perfect synchrony. Then it stopped. The only thing left was a faint oscillation at the frequency of hydrogen. The boundary Voyager reached wasn't the end of the solar system. It was a mirror field, a curvature in space-time where radiation folds back on itself. The gravitational echo wasn't an answer. It was the sound of our own message being caught and returned. And hidden in the smallest harmonics was a timestamp, a countdown. When decoded, it aligned with the year 2031. No one could explain it, but one scientist described it as a synchronization marker. It's not coming toward us. It's aligning with us.